Before setting up the Hello World demo app of the electronics world, which is the blinking LED, let's have a really quick look at the Arduino ecosystem. The members of this ecosystem are bits and pieces that come together when you build an Arduino project. The Arduino ecosystem is made up of these parts: the Arduino board, the Arduino IDE, the Arduino core software library, third-party software libraries, shields, and lots of components. In the beginning, way back in 2005, there was only one board. Rumor has it was called the Arduino in honor of the place where the idea for an open source hardware prototyping platform was conceived. Today, there are numerous boards with a wide range of capabilities. Processing, input, output, power consumption, size, and price are various metrics in which modern Arduino boards differ from each other. Arduino official boards are made by companies that work in collaboration with the Arduino team to ensure compatibility. They are the only ones licensed to use the name Arduino. In return, makers of official Arduino boards pay a fee to the Arduino project. There are also many clones, derivatives, counterfeit boards that, while using the open source Arduino software and schematics, do not contribute to the project financially. They also are not providing any guarantee of compatibility and quality. I recommend you only purchase an official Arduino board for both peace of mind and for the nice feeling of contribution to the project. The Arduino IDE, or Integrated Development Environment, is a tool you use to create an Arduino program and upload it to your board. An Arduino program is called a sketch, a reminder that what you're actually doing is prototyping, which in turn means that anything you do is subject to trial, testing, and change. The Arduino IDE can be downloaded from the Arduino website and works on Mac, Linux, and Windows computers. Its only requirement is the Java runtime environment. Simply download the IDE installer for your computer and run it. The installer will let you know if you need to download the JRE. Get it from the Arduino website /main/software. With the IDE installed, you will be able to type, upload to the board, and debug, which means fix, your sketches. You also use the IDE to communicate both ways with the board, to upload your sketches to the Arduino and to receive messages from the Arduino. When you download the Arduino IDE, you also get the Arduino core library. This library is a collection of functions or methods that allow you to control the various aspects of your board's functionality. For example, if you want to read an analog value from pin number 1, you call the relevant method like this: analog read (1). The 1 inside the parenthesis designates the number of the pin that you want to use. It's awesomely simple. If you want to turn an LED light on, that requires writing a digital value 1 to a digital pin. Connect the LED through a resistor to digital pin 13, for example, and use this method: digital write parenthesis 13, high, close parenthesis, where 13 is the number of the digital pin you want to use, and high the value that you want to write to it. In digital pins, there are only two possible values, high and low. Apart from methods like these, meant to interact with the environment, the Arduino core library gives you many others. There are control structures, arithmetic operators, mathematic operators, and many others. All of them are listed and documented in the references page of the Arduino project's website. I will be explaining the use of many of these methods as we use them throughout this course. Lots of people have contributed to the Arduino ecosystem by writing their own libraries and making them available to others. These third-party libraries often address gaps in functionality that the core library perhaps does not offer, or it does not offer well. In other cases, these libraries often offer alternative ways of doing things. For example, there is a library that allows you to add infrared remote control capability to your project, or another one that allows you to implement a web server that runs on your board, which is very useful for remote sensing or remote control applications. Very often, certain hardware components are used so widely that eventually a company assembles them together on a printed circuit board so that it is easy to plug into an Arduino board without any wires. These extension boards are known as shields. The Ethernet shield is a very common example. It makes it easy to add Ethernet and Internet communications to your project. You could just buy a WISNet controller, connector and other parts and create your own Ethernet adapter, but it would be silly. Remember that our mission is to build prototypes so that we can implement our ideas, not to fiddle around with problems already solved by others. Another popular shield is the Arduino motor shield, through which you can control all sorts of motors, very useful if you want to build a robot, a racing car or a remote control lawnmower. In section 4, we will be playing with the Ethernet shield. Finally, there are the individual components. These are typically small devices that you plug into your board by using jumper cables and breadboards. For example, if you want to take temperature and humidity readings, you could use the DHT11 sensor. It's only a couple of dollars in price. If you need to measure distance, then you could use an ultrasonic distance sensor. Again, very simple to use and very cheap. In sections 2 and 3 of this course, we will be explaining and experimenting those useful components. Okay, that concludes a brief dive into the Arduino ecosystem. Please take a few minutes to answer a few quiz questions before continuing with Lecture 3, where we'll be examining the Arduino tools and the prototyping process.